Embark on an extraordinary voyage into the frontiers of agricultural innovation, where the fusion of science and farming yields a cornucopia of breakthroughs. In this video, we unveil an assemblage of mind-blowing machines and tools that are propelling the art of agriculture into a new realm of possibilities. Immerse yourself in the wonders of hydroponic growing systems that defy conventional soil-based cultivation, automatic fruit sorting machines that revolutionize post-harvest processes, electric weed trimmers that wage war against unwanted intruders, solar-powered water pumps that harness the sun's energy, and infrared crop drying technology that ensures optimal preservation. Together, they epitomize the cutting edge of farming ingenuity. Number 5. Hydroponic growing system. The cultivation of plants through the use of hydroponic growing systems is a method that does not include the use of soil. Instead, plants acquire the vital nutrients they need straight from a nutrient-rich water solution. Hydroponics is a method of plant cultivation that does not require the use of soil. Instead, plants are grown in a soilless medium such as perlite, vermiculite, rock wool, or coconut coir. They are given a nutrition solution that has been properly balanced to include all of the important minerals and elements that are required for their growth and development. The nutrient solution is often comprised of a combination of water and several fertilizer formulations, each of which is formulated specifically to meet the requirements of the plants that are being farmed. The administration of both water and nutrients needs to be precisely controlled in hydroponic systems. Monitoring and adjusting both the pH level and the electrical conductivity, EC, of the nutrient solution are required in order to ensure that plants are able to make the most efficient use of the nutrients. The EC value gives an indication of the concentration of dissolved minerals in the solution, whereas the pH level has an effect on the availability of nutrients. Number 4. Automatic fruit sorting machine. Automated fruit sorting systems are cutting-edge agricultural technologies that are designed to sort and grade fruits based on a variety of criteria, including their size, color, shape, and overall quality. Automated fruit sorting systems make use of optical sensors and cameras to take pictures of each individual piece of fruit. These sensors do an analysis on the fruit depending on certain criteria and qualities that have been established beforehand. In order to identify flaws, evaluate the fruit's quality, and select the correct sorting category for each individual piece of produce, sophisticated image processing algorithms are utilized. The criteria used to sort fruits can change depending on the specific demands placed on the sector, as well as the type of fruit being sorted. Size, color, form, ripeness, flaws, and exterior defects are typical characteristics that are evaluated. These factors will determine how the machines are designed to separate the various types of fruit into their respective groups. The fruit that needs to be sorted is often moved through the machine using a conveyor belt or chute system, which is a part of most fruit sorting machines. The optical sensors scan the fruit as it travels along the conveyor belt or through the chutes. This movement can take place either horizontally or vertically. The system has the potential to be constructed to manage a large quantity of fruits, which will allow for more effective sorting and processing. Number 3. Electric weed trimmer. An electric weed trimmer, also known as an electric string trimmer or electric weed eater, is a portable garden equipment that is used to trim grass, weeds, and other plants in areas that are difficult to reach with a lawnmower. Other names for this item include an electric weed eater and an electric weed trimmer. Electric weed trimmers are powered by electricity and can either have a corded design that plugs into an electrical outlet or a cordless version that runs on batteries and is completely cordless. Corded trimmers offer a constant power source. However, the length of the power cord places a restriction on their usability. Cordless trimmers provide greater mobility than their corded counterparts, but have a shorter runtime due to the lower battery capacity. Electric weed trimmers include a cutting mechanism that consists of a nylon string or line that rotates at high speeds. This keeps the string or line sharp. The rotating line strikes the grass and weeds and cuts through them, so removing unwanted growth. Some models additionally come equipped with a cutting blade or accessories that can be utilized for the purpose of pruning thicker vegetation or getting into more confined areas. Electric trimmers frequently come equipped with a cutting head that can be adjusted, enabling users to effortlessly convert between trimming, edging, and several other cutting modes. Because of its versatility, the trimmer can work well in a number of different parts of the garden or lawn. Homeowners and gardeners will find that electric weed trimmers are often easy to use because they are user-friendly in terms of weight and maneuverability. They have ergonomic handles and controls so that the operation can be done comfortably even over long periods of time. Number 2, solar-powered water pump. A device that draws water from a water source, such as a well, pond, or reservoir using solar energy, is referred to as a solar-powered water pump. This type of pump can be powered by the sun. Solar-powered water pumps come outfitted with solar panels, which are responsible for absorbing sunlight and transforming it into usable electrical energy. These panels are made up of a number of photovoltaic, or PV cells, and when they are exposed to light, they produce electricity in the form of direct current, or DC. The direct current DC motor that operates the water pump is powered by the electrical energy that is produced by the solar panels. Depending on the type of pump and the task at hand, the device may generate either suction or pressure in order to pull or push the water. There are various solar-powered water pump systems available, some of which incorporate a controller and battery. The controller is responsible for regulating the flow of electricity from the solar panels to the motor in order to get the most out of the system, while also preventing it from overloading and becoming damaged. When there is not enough sunlight, or when it is nighttime, the excess energy that is produced by the solar panels can be drawn from the battery. Different kinds of solar-powered water pumps, such as centrifugal pumps, submersible pumps, and surface pumps, can be broken down into their respective categories based on the specifics of their designs and uses. The particular model of pump that is purchased is determined by a number of parameters, including the supply of water, the required total dynamic head, TDH, and the flow rate that is preferred. Solar-powered water pumps find usage in a variety of contexts, including the irrigation of agricultural land for agricultural reasons, the watering of livestock, the provision of remote water supplies for residential areas or communities, and the circulation of water in ponds or other water features. These pumps are especially helpful in places that do not have access to grid electricity, where grid electricity is inconsistent or where it is expensive to get. Number 1. Infrared crop drying technology. The term infrared crop drying technology refers to the practice of drying agricultural crops with the aid of infrared radiation. The infrared crop drying technology makes use of infrared radiation, a type of electromagnetic radiation that has wavelengths that are longer than those of visible light. When infrared radiation is focused on crops, it is able to permeate the crop material and deliver heat to the moisture that is contained within the crops in a direct manner. Because the moisture in the crops absorbs infrared radiation, this radiation is converted into heat energy, which in turn causes the moisture to evaporate. The heat that is produced encourages the release of moisture that is contained within the crops, which speeds up the drying process. When compared to more conventional drying processes, the infrared crop drying technology is renowned for its superior energy efficiency. It lowers the need for significant heating of the air around the crops, which results in decreased energy usage. This is accomplished by directly heating the moisture that is contained within the crops. During the drying process, the quality of the crops can be maintained with the assistance of infrared crop drying technology. Overdrying is a factor that can result in nutrient loss, color deterioration, and a general decline in the quality of the crop as a whole. The mild and controlled heating that is delivered by infrared radiation helps prevent overdrying. When compared to more traditional drying processes, crop drying technology that utilizes infrared has the potential to produce faster drying timeframes. The elimination of moisture from the crops can be accomplished more quickly and effectively thanks to the direct application of heat to the humidity found within the plants, which also cuts down on the total amount of time necessary for drying.